Welcome to another video on ALS Software Engineering Program. And in this video, we want to work on the project, the 0x14.c, which is the bit manipulation. The first question that will come to your mind is, what is bit manipulation? In the computer memory, the system do not understand if a data is a string, if it is an integer or an array or whatever data type it is. What the system understand is 0 and 1. So when it comes to bit manipulation, what they want us to understand is how to manipulate this data using some operators. So there are different operators which will be used to manipulate this data. But before I go on, ensure you cover the project resources, that is if there are any. Ensure you read the requirements and ensure you cover everything before we move ahead. But however, I have a link here which will give you a proper understanding of how bit manipulation works. Okay, so here is the link. It talks about different operators on how to use and how to understand the bitwise operator. Okay, so you can see them here. This is the bitwise AND, this is the bitwise OR, this is the bitwise exclusive OR, and this is the bitwise shift, and this is the bitwise shift right. So I'm going to drop this link on the description, so ensure you look at it. And also there are some given examples here which you can copy and run on your own. So you can run it on the online compiler, which is Programmate. I am also going to drop this link on the description below. So with this understanding, right, I will assume that you have covered all the resources. What we want to do now is to log into the class server, which is the sandbox, and start the project implementation. Alright guys, welcome to the quiz section. It is important you cover the project resources, so if you have not, ensure you visit this link which I have in the description below. It's going to give you a proper understanding of what is going on. Alright, so the first question, which is question 0 in the quiz section. So what is the output of this? So it's going to output this. While question 1 says, what is the output of 0x89 in base 2? Well, this is the result. For question 2, what's the output of 0x12? This is the output. For question 3, 0x001, if we shift it by 1, this is what the result. For question 4, this is the bitwise OR. The bitwise OR between these two, what is the result? This is what the result. For question 5, it says, what is 98 in base 2? This is what the correct answer. For question 6, it says, what is this in base 10? Okay, this is the correct answer, which is 82. For question 7, 0x02, if we shift it to the right by 1, this is what the correct answer. For question 8, this is the bitwise OR between these two numbers, and this is the correct answer. For question 9, this is bitwise OR between these two numbers. This is what the correct answer. For question 10, it says, what is this in base 10? Right, so this is 137. And for question 11, it says, what is 98 in base 16? If you run that, you see this is what the correct answer. For question 12, if we shift it to the right by 3, this is what the correct answer. And for question 11, The bitwise OR between these two value will give us this answer. For question 14, the bitwise AND between these two value will give us this. For question 15, the bitwise AND between these two will give us this. 16, the bitwise AND between these two will give us this. 17, what is the output? What is this in base 16? Right, this is the correct answer. 18, the bitwise OR between these two will give us this. 19, the bitwise 19, if we shift this to the left by 1, it will give us this. Alright guys, so let us move to the task section. Welcome to the task section. And in this task section, the first thing we should do is to log on to our sandbox. So you can use your web terminal. For me, I'm going to use the SSH. Alright, so I'm going to click on this and I'm going to paste that on my console. So I'm going to paste that on my terminal and click enter. So next, you want to input your password. Under my username, you're going to get your password. All you just need to do is to click on it and input it on the console. So I have copied my password and I will just paste it here. It won't show, but after the paste, you just need to press enter. And you can see I am in. Right, so what we want to do next is to work on the task. But first, you will notice we are given a prototype, and if you have read the project requirements, you will notice all the prototype should be in the file main.h. All right, and we also need this file underscore pusher. All right, so the first thing I want to do is to locate the project directory. So if you scroll down, you can see we should be working in this GitHub repository, the ALX low level programming. So you want to locate that folder quickly. Okay. So I want to locate my okay. So next you want to create this folder. You want to create this directory, which is the 0x14 bit manipulation. So you can do mkdir haru and paste. Okay, enter. All right, so you can now cd into that directory, and the first thing you want to do is to create the readme file. So you can create the readme.md file. Then it should not be empty. So I'm just going to put the name of the project I'll be working on. You can see, and I have what the readme.md file. Just like I used to do, I need to get all the prototype in my main.h file. Okay, so let me get mine quickly. ALX low level programming. Then this is 0x14 and main.h. Okay, so I now have my main.h. Okay, let me check for the underscore pusher. I'll also get the underscore pusher to the current directory. Okay, so let me clear my screen. And you can see I have what's the main.h. So this is the main.h. So these are all the prototype. So what I used to do is to copy all the prototype. Some tasks do have prototype, why some do not. So you can see this one, which is binary to int. And if you look here, you can see this is what binary to int. So when you've done that, ensure you test your code to make sure everything is good. So you can test your code using Betty main.h. And if there is no error, it means everything is good, just like mine. So the next thing you want to do is to work on tag 0. So it says write a function that converts a binary number to an unsigned integer. So they've given us a prototype already, and it says where b is pointing to a string of 0 and 1 character, return the conversion number or 0, right? So what I'm going to do is the solution should be in this file, which is 0 dash binary underscore unsigned int.c. Okay, so let me get mine. I'm going to get mine to the current folder. All right. So I'm going to use my vim command to display what is in the content of that file so that we can see. So what is going on here is you can see this is the name of the function which they've given us here, binary to int. All right. So now what we are doing here is if there is no value, right, all you just need to do is to return 0. So this is where we're doing the calculation, right? This is where we're doing the calculation for the binary to integer. So once that is done, we want to return the binary to integer after the conversion. Okay, so once you've done that, right, we want to change the permission of this file. So you should be able to read this file. You should be able to read, write, execute this file. So I want to change the permission of this file and also the main.h. I think I should just change the position of this one too. Okay, so if I check now, you can see I now have read, write, execute. Okay, the next thing we want to do is to create the test file, which is 0-main. We need to create this file, and this is the content of the file. So I'm going to use my vim command to create that file. Okay. We also need to change the permission of this file. Let me just give this one 777. Okay, good. Alright, you can see all the file now has was a read, write, execute for me. So the next thing I want to do is to run the gcc command. So I'm going to run a gcc command, enter. It should generate an executable file, and that file name should be A. So let us check. In future, you can see this is the file name, and we want to run that file like this. So let us run that file ./a, enter. So we have 150984. If you check here, you can see we have what? That same result. So at this stage, you want to do your git add, git commit, and git push. So we are done with tags 0. So next, we want to work on tags 1, and it says write a function that prints the binary representation of a number. So we're given a prototype, and do not forget that this prototype has been added to the file. It has been added to the file, the main.h. Okay, look at it, print binary, and you can see it should be here, print what? Binary. Okay, so it says format, right? See example. You are not allowed to use an array. You are not allowed to use malloc. You are not allowed to use percent or slash. Okay, so the solution for this problem should be in this file one dash print underscore binary. Okay, so let me get my solution. So you can write yours in the file one dash print underscore binary. All right, so let's see what we have here. All we are doing here is if the number is greater than if the number is greater than 1, all we need to do is to print the binary representation of that number. All right, so at this stage, we need to create a test file, which is the example file they're giving us, one-main.c. So we're going to copy the contents of that file, and you're going to use your vim command to create that file, one-main.c. Enter. I for insert, then paste what you have. So I'm going to save. The next thing we need to do is to change the permission for this file. So as a current user, you should be able to read and write and execute. You should have all permission. So I'm going to change the permission for one-main.c, main.c, and one-print. Okay. So if you check that, you will see we now have what the read, write, execute for these two files. So the next thing we want to do is to run the GCC command to compile the solution. So it should generate a file, an executable file named as B. I'm going to press enter. If there is no error, everything is good. So we should run the solution just like this. We're going to run the executable file. So we have this 0, 1, and a whole lot of this. So if you look at it, you can see we have what? The same result. This shows we've done well, and we want to do your git push, git add. Next, we move to task 2. It says write a function that returns the value of a bit at a given index. Okay, this is a prototype, and this is the argument. So you see where index is the index starting from 0 of the bit you want to get return. Okay, sorry. Where index is the index starting from 0 of the bit you want to get. Return the value of the bit at index, which is the given index, or -1 if an error occurred. So the solution to be in this file, right? So I need to get my solution. Okay. So you can write your solution into -get underscore bit.c. So I've gotten my solution, and let us see what we have in there. So what is going on here is this is the bit, and these are the argument that was passing. So it is now parameter. So now when we declare the value bit here, so we're assigning it to the index. So we're going to check if it's greater than 32, it means it is out of range. We want to return -1. Else we want to return the bits and 1. Okay. So the next thing we want to do is to create the test file, which is the specimen file which was given to us. Note the name 2-main.c. So I'm going to copy the content of that file and create it. And I'm going to save. The next thing is file permission. If there's no file permission, we will not be able to execute this file. So I'm going to create read, write, execute for everybody for this file. Okay, so the next thing we should do is to run the GCC command. So this command is going to generate an executable file, which is C. See, if I press enter, if there is no error, it means everything is good. Remember to always check your code using Betty. There are sometimes you will push your code to the cloud and it won't get checked. It will be throwing error. So you can check your code using Betty like this. Sorry about that. So if there is no error, it means everything is good. But if there is error, right, there is a way you can correct that. Because Betty used to point out a particular number, so you can do set number here. So it's going to show you where the exact problem is. So instead of guessing, you just need to solve that problem. So all right, we have changed the permission of the file. We've also run the GCC command, and next we want to run the executable. C for enter. So we have 0, we have 1, 1, 0. So we have the same result. That shows we've done well. And at this stage, you want to do your git add, git commit, and git push. And next, we want to move to task 3. Task 3 says write a function that sets the value of a bit to 1 at a given index. This is the prototype, and this is going to be the name of our function. These are the arguments. Okay, and it says where the index is the index starting from 0 or the bit you want to set. Return 1 if it worked, or -1 if an error occurred. Note the solution should be in this file. Alright, so the solution should be in this file. I want to get my solution to the current working directory. So you can write your solution in this file, which is in 3-set-bit. Let's see what we have here. So you can see this is the name of the function and this is the bit. So if it's out of range, we want to return -1. It means everything is not going well. If everything went well, we want to return the pointer to that bit. Sorry, this is the pointer to that bit and we just want to return 1. So we are returning either -1 or 1. So this shows we've done well. And at this stage, we need to test this result. So this is the sample file they're giving us, 3-main. We want to copy it and create that file, 3-main.c. So enter. And the next thing we want to do is to paste what we've copied here. And I'm going to write it. So next is to change the file permission for this new file, 3-main.c and 3-set-bit.c. Okay, so if we check now, we now have a read, write, execute for this new file. So the next one of these to execute this file using the GCC command, and this command should generate an executable file, which is D, right? So I'm going to press enter. Now, if you check, there should be a file which is D. All right, so we want to run this file like this. I'm going to run the file ./d, enter. So it gave us two results: 1056, 1024, and 99. So if you look at this, you can see it is the same, and we've done absolutely well. So do your git add, git push. Then we'll move to the next task. So for task 4, it says write a function that sets the value of a bit to 0 at a given index. So this is a prototype which is in the main.h, and this is going to be the name of our function too. So these are the arguments, but when we're writing it, it's going to be the parameter. So it says it says where index is the index starting from 0 of the bit you want to set. Return 1 if it work, or -1 if an error occurred. Alright, so the solution should be in this file, which is 4-clear bits. Right, so I'm going to get my solution here. So the solution should be in the file 4-clear bit. I'm going to get it in the current directory. So let's see what we have here. So if you look at what we have, you can see this is the mode function clear bits, and since it's not possible, we just return -1. Okay, and since we were able to clear the bit, right, it is in the range, and we just return 1. It means everything is successful. All right, so next thing to do is to create the example file, which is 4-main. So I'm going to copy the content of the file like I used to do. I'm going to create that file. And I'm going to save. Ensure you test your file with Betty to avoid possible errors. Okay, so the next thing I want to do is to change the file permission of this file. Okay, so I'm going to use chmod. This time I'm going to use 700. The important one is the 7 at the front. It gives me the user, which is read, write, execute. So 4-main, 4-clear bit. All right. Now, okay, you can see for these two files, as a user, I have read, write, execute, and no permission for others. All right. So next, we want to run the GCC command for our new solution, and it should generate a file, which is an executable. The name of that file is E. Okay, it says command not found. Definitely, I must have done a mistake here. Okay, so I copied extra. I'm supposed to copy from this site. Sorry about that. So I'm going to do that again. Now, there's a new file E, and we want to run that file. You can see just as how they've done here. So if I run that file, we have 0096. And if we check what we have here, you can see this is 0096. So we've done well. Do your git add, git push, git commit, and git push. So moving to next task, which is, I think it's the last mandatory task, yes. So it says write a function that returns the number of bits you would need to flip to get from one number to another. This is the prototype, and this is going to be the name of our function. So it says you are not allowed to use percent or slash. All right, the solution should be in this file 5-flip bits. Okay, so let me get my solution. I'm going to get my solution to the console. So let's see what we have here. So all we need to do is to loop through the given value, and once we check that, all we need to do here is to sum up the possible number we can flip. So then we'll return that number. This is the result we want to return. All right, so Now we need to create a test file to ensure if everything is good. So the name of this file is 5-main. So I'm going to create that file 5-main.c. Okay. Sorry, let me copy the content of the file. Okay. All right. So I just created the test file. We need to change the permission as usual. 5-flip and 5-main.c. The next thing is to run the GCC command to compile the solution if everything goes well. So this command should generate an executable file, which is F. So if there is no error, everything should go well. And I want to run the file, which is F. So we have 2531. So we have 2531. All right, so we've done well. All you need to do is to do your git add, git push. So guys, thank you very much for watching. If you find this video interesting, ensure you like and subscribe. It gives me more motivation to create more video. Thank you very much. I'll see you in another video.